Here's the video for section 7.2. This is Math 800. We're going to learn how to factor trinomials. So in this, we are going to do factoring a trinomial when the leading coefficient is a 1. In other words, it just starts with an x squared. And we're also going to do factoring of a trinomial when you have a common factor, the greatest common factor, like we did in 7.1. And then what's left is a trinomial with a leading coefficient of 1 that we're going to factor. So those are the two things we're going to do in this lesson. So factoring, as you may have noticed, it's kind of like unmultiplying. There was some multiplication done, and now we're working backwards to figure that out, right? So remember how we multiplied. If you multiply these two binomials together, here's what you get, right? You have, this came from x squared. There's our x squared, and then we had a 4x, and then we had a 3x, and then we had a 12. But these two we added together to get like terms, and because they were like terms, and we got a 7x. So if you notice, that 7, it came from the 3 and the 4, and it was this 3 and 4, right? So because there's only an x in the first spot, right, then of course when we multiply x times 4, we just get the 4x, and we just get the 3x. And so we end up with those two numbers, the 3 and the 4 added together give us our middle term with the x term. But the constant, it's made up of 3 times 4, because that was where, let me get rid of some of my marks here. But that was where we multiplied these two things together and got the last one, right? And that's how it's always going to be. We're trying to figure out those two numbers. And we know what they multiply to, and we know what they add to. So it's kind of a puzzle. We're figuring out what two numbers can I multiply to get something and add up to get something, right? So that's what we're looking at here. Now, look, we have the same 12, but this time it has to add up to 8, right? So we're looking for something that multiplies to be 12, but adds up to be 8. Now you notice that this plus here means when we multiplied the two of them together, we got a positive number. That means they were either both positives or they were both negatives. So, and since they have to add up to positive 8, they must have been both positives, right? So if you think about 12, and let's start with the factors of 12. And here's a little table where they've listed all the factors, ways that you can get 12. You could do 1 times 12. You could do 2 times 6, or you could do 3 times 4. All right, so 1 times 12, that would add up to 13, right? And we saw in the last screen that 3 and 4, that would add up to 7. But if you add that 2 and the 6 together, that adds up to 8. So it's the 2 and the 6 that we want to use. Those are our two numbers with our binomials. So here they are. Here's where we put them. Right here and right here. Now, this is only going to work because the first term was an x squared, and so these two had to be a plain old x. In the next section, in 7.3, we'll talk about those trinomials where it starts with a number other than just x squared. All right, so let's look at another one. Here we have two numbers. They have to multiply to be negative 20. Now, because it's a negative, for us to multiply two things and get a negative number means that one of them has to be positive and one of them has to be negative. I don't know which one, but one of them has to be positive and one of them has to be negative. And we add those two numbers together, even with their negative sign and positive sign, right? We have to get negative 8. So once again, we're looking for factors of 20. So here are all the factors of 20. We 1 in 20, and we could have the 1 negative and the 20 positive, right? But if we added these together, that would add up to positive 19, right? And these two, 1 and negative 20, well, that would add up to negative 19. We're looking for negative 8, right? So negative 2 and 10, that adds up to positive 8, so we're close. 2 and negative 10, that adds up to negative 8. So it really doesn't matter about the last two. They add up to 1 and negative 1, right? But we can stop as soon as we find it. We don't have to list all of them. But in order for you to know, you can't give up unless you've listed all of them, okay? If we look through every single set of numbers that could multiply to be 20 and none of them add up to be negative 8, then I would know I can't factor this, okay? All right, so there's the negative 8. So now, did I put it on this side? No. So we could write y minus 10 and y plus 2. Or, I think I left off the other answer. We could also have the answer y plus 2 and y minus 10. Okay, so here's kind of the sum up. You're finding two numbers that multiply to be C and add up to be B. If C is a positive number, then they both have the same sign. And if B is positive, they're both positive. And if B is negative, they're both negative. Now, if C is a negative number, then they have opposite signs. All right, so we'll practice them. Well, first let's talk about the other objective we're going to have. So remember I told you that when you learned how to do the greatest common factor, you were going to keep using it over and over again. And no matter what, I'm going to teach you a bunch of different times that we factor and ways that we factor. But the first thing you always have to do is check and see if there's a greatest common factor. So when we look at this, the first thing we have to look at is there a greatest common factor other than 1, right? Bigger than 1. All right, so if we look at these three terms and we see that they all have a 5 in them and they all have an x in them. So that greatest common factor is 5x. All right, so we factor out the 5x. Just like we did in the last section. And if you're worried about or wondering how you figure those out, we're doing that by dividing by 5x. And that's how we get these three. So this would cancel x cubed over x squared. So that's where I got that x squared. This would cancel, get 3 x squared over x. That's going to be x, so that's where I get my 3x, and it was negative, right? And the last one I ended up with 2. 10x over 5x, okay? So now I factored out the greatest common factor. Now this is factored, but it's not completely factored because I have to see whether I can keep going. So this term inside here is now a trinomial that looks like the ones we've been factoring, right? I need two numbers that multiply to be 2, but add up to be negative 3. So they multiply to be positive 2. They have the same sign. And since they're adding up to negative 3, it's got to be a negative sign. All right, so we're looking for factors of 2. Well, we only have 1 times 2, right? And so if they're both negative, that's negative 1 and negative 2. And if you add them up, that gives us negative 3. So we write the factored part. Now, don't forget this part we factored out. Oops. Sorry. The part that we factored out, the 5x, that's got to be part of the answer. Don't forget that part. Sometimes people factor it out and then forget that it exists and leave it out. But when you multiply this out, it has to be right back to where it started. And so this is completely factored. Now, we know for sure it's completely factored if we have everything down to monomials and binomials. Okay? Especially binomials with a x to the first power. As we'll see, there are some binomials we can keep factoring if the x is squared or something like, or bigger. Okay? All right, so here's another one. So first of all, I want you to find the greatest common factor. So pause the video for a minute, figure out the greatest common factor, and factor it out. Okay, so hopefully you saw that 10, which is this one, goes into all of them. So 10 is the greatest common factor of the numbers. And then the y's, if you notice, y cubed is the smallest one, and y cubed would come out of everything. So the greatest common factor is going to be 10y cubed. So if you factor that out of everything, you should have ended up with y squared minus 2y minus 8. Okay, so now we want to keep factoring. So I want you to now pause the video again and find 2 numbers that multiply to be negative 8, but add up to be negative 2. All right, so hopefully you found that negative 4 and positive 2 multiply to be negative 8, but when you add them together, you get negative 2. All right, so don't forget the 10y cubed. Don't forget that part in the answer. And the rest of it is y minus 4 and y plus 2. All right. There are times when you look at all the factors of a number and none of them will add up to be what you need it to be. And if that is true, then it is not factoring. If you've looked at all of them and none of them add up to be the right thing, then it's not factorable. So they give this example, and let's look at the factors of 4, and it's positive, so they have to be positive, right? So we have 1 and 4, or 2 and 2. So 1 and 4 add up to 5, and 2 and 2 add up to 4, so nothing adds up to 3, and there's no other way to get a 4. So this is not factorable. In this book, mostly we say not factorable. Other words that you might see are prime. We call a polynomial prime if it can be factored, or irreducible. Those are other ways of saying it, but most of the time this book is just going to say it's not factorable. All right, so here's some practice for you. Some of these have a greatest common factor, and some of them don't. So figure out, check first for a greatest common factor, and factor it out, And don't forget to write that part in your answer. So pause the video, and when you come back, I will show you the answers. If you want to see any of these worked out, let me know in class and we'll work them out. Okay, here are the answers. And of course, as we've mentioned several times, the answers could be switched. The order could be switched. For example, in number A, instead of being x plus 5, x plus 7, maybe you got x plus 7 and x plus 5, so it doesn't matter. Multiplication is commutative, so it doesn't matter the order of the factors.